Hello, in this podcast, we're going to be learning about solar energy, and our learning targets are to describe the ways we obtain energy from the sun, to list the advantages of solar energy, and to list the disadvantages of solar energy. First of all, solar energy is a renewable energy source because we continually receive more energy from the sun. First, we're going to look at passive solar heating. Passive solar heating all comes about in the way a house is designed. As you see over here is an example of using the sun to passively heat the house. Down this diagram over here, this shows how different features in there work. There are windows that go from the floor to the ceiling, and that allows the sunlight in to heat the home. The floors, especially in the walls, are made of a material that can absorb the sunlight and will slowly re-radiate that heat back out to the house, and that's normally made out of brick or tile or concrete. Time when you want to have the heat from the sun is in the winter. You don't want it in the summer. So in order to keep the house in the shade, the windows have the overhang that you see here, and that blocks the sunlight during the summer. The cost of building these houses is no more than 5% than conventional houses, and is sometimes cheaper than conventional houses. It's good to also have another heating source with it, and people who have this find that their heating bills are profoundly less. Like rather than having a heating bill for the winter of thousands of dollars, the heating bill is less than $100. Next, we come to an active solar water heater, and this video here will show you about active solar water heaters and how these things work. And the video here was taken in New Jersey during the winter.
One thing people seem to miss still is that you can make hot water when it's really cold. It's about 25 degrees out today, and we're producing some significant hot water today, so take a quick look. All right, so here's the collector, and let's check out our data real quick. So here we go. This is the outside temperature right now is, you can see it there, 25 degrees. And our collector, sensor 1 is the collector itself. So it's 25 degrees outside, and we've managed to turn that sunlight into 138 degree temperatures. So we can go back and basically look. Right inside here, inside this manifold, it's 138 degrees, even though it's 25 degrees outside. And it's just from that, right there. All right, so as I mentioned, sensor 1 is the collector, but sensor 2, 3, and 4 are inside the tank, 4 being the one at the top of the tank, 3 in the middle, and 2 at the bottom. So with this 138 degree fluid that we have in the collector, we can heat some significant water, and the day's not over yet. So we're already at 80 degrees, and it's an 80-gallon tank. Here we are around 2 p.m. And at 3 o'clock, the sun's capabilities are starting to wind down. But for February, with some cloud cover, having 80 gallons of 80 degree plus hot water for free isn't bad. But the point of this video is that outside temperatures don't reduce the energy in light. If we were in the Arctic, we could do the same experiment here in New Jersey. Now, of course, angle of sun, length of day, and insulation on the piping will affect our temperatures. But the point is, if it's very cold, heat still exists in sunlight.
Okay, so as you saw in there, that was more of a modern design than the diagram that we have over here. But basically, there's a solar collector, and the collector is designed to heat the water that goes through it. What we have here is we got a collector that's in a box rather than having these tubes that you saw in the video. The box is insulated and the inside of it is painted black. There's a double layer of glass that goes on top of it. It's a double layer because there the air in between the glass acts as an insulator and it keeps the heat in. As you saw in the video, the air there can get very, very hot even in the dead of winter. That water that gets heated then gets transferred to the hot water tank, and the cold water then circulates back out. And as you saw in the video, it works quite well to heat the house even in the winter. A lot of the hot water heaters, you have the option of having an extra heating source in there, and that'll be very good in cases where the collector isn't heating stuff up. Like, for example, at night you're washing clothes, you're doing the dishes, taking a shower, you end up using up all the hot water, and there's no sun to reheat that water. Or let's say in the winter, you've got a heavy snowstorm and the collectors get all covered with snow. So in that case, you end up with no hot water for a day or so. Next, we come to high temperature solar energy. This is very useful in tropical developing countries because in a lot of these places, without this, they may end up using coal or wood-burning stoves inside of their houses, and that greatly increases the indoor air pollution there. And particularly with things like coal, the stuff that burns with coal can cause cancer and many other problems. The parabolic mirror produces very high temperatures and intense light, but it is dangerous. Like if you stick your hand in where the focus is, which is where the heating is, you'll end up getting severely burned because the temperatures there get quite hot. A second kind that's much safer, and this is one that you're going to be making when it starts getting sunny and hot outside, is a solar box cooker. Mirrors reflect the light into the box, and the box, as you see there, has a dark color to absorb the heat rather than reflect and focus the heat into the box. And the glass lid helps keep the heat from escaping, but the temperature can only reach 120 degrees, so this is more of a slow cooker. It can still cook everything, but it's like a crock pot. Now we come to solar thermal electric power. So rather than using solar energy just simply to heat things and using that heat, now we're using it to make electricity. And these are actually power plants, which can power thousands of homes. It's actually possible to make big enough power plants in the American Southwest to provide enough electricity for the entire continental United States. Two reasons why we don't do this is one is being able to build all of that, and the other is that the entire electrical grid would have to be redone in order to do that, and that's very expensive, and I don't see much pressure in the way of pushing the United States government to undertake a project like that. So there are basically two methods of solar thermal electric power. This is the first one. Next slide is the second one. And if you look at this diagram here, what you see is that you've got a bank of parabolic mirrors, and in the center, in the focus of those mirrors, there's a tube, and inside of that tube is a liquid. That liquid generally is oil. It's not going to be water because the temperature will be hundreds, maybe even 1,000 degrees inside of that liquid. So you need a liquid that is liquid at that temperature. That's why they use oil. And that liquid is pumped through there, and it gets heated up by those mirrors. And then it goes to a turbine where it comes in contact with water. And that heat turns that water into steam, and that steam turns the turbine, which turns the generator and creates electricity. Rather than using the heat from burning fossil fuels to produce steam, we're using the sun's energy to heat up oil, which produces steam. Now, if you look at the diagram up here, you can see here a method so that this solar power plant can produce energy 24/7. Because obviously, in the dead of night, it's not going to be producing electricity. It is going to produce electricity on cloudy days. It just won't be producing as much electricity. When it's hot, that hot oil has two routes to go. One is to the turbine to produce electricity, and the other, it goes to this hot storage tank over here. And then when there's not enough light to make the hot oil, then the hot oil comes out of the hot tank, and that is used to produce the electricity. Here's the second method of solar thermal electric. Then what happens here is that there's a whole bank of mirrors that surrounds this power tower. All of these mirrors track the sun, and they focus all the light of the sun that hits them onto one point in the tower. And that tower contains molten salt, and it gets heated to 1,000 degrees Fahrenheit, which is 500 degrees Celsius. That molten salt boils the water, and that steam drives the turbines. One environmental disadvantage to these thermal power plants is that there's some impact on the environment in that where these mirrors are placed, that it's a little bit disruptive to the environment. In those areas, you're going to keep it clear of plants, and also that land cannot be used for anything else. But even so, it's a very small area, and relative to what's done in terms of land use for fossil fuels or hydroelectric power, it's really very, very minor. Next is photovoltaics.
The action never stops at the FedEx Regional Sort Facility.
There's more than 250,000 packages that transit this facility in a given day. And we, in a month, are using approximately 450 to 500,000 kilowatt hours of power.
To meet these electricity demands, FedEx decided to build its own power plant. It's silent, has no moving parts, and it's located conveniently on the roof. Taking advantage of abundant sunshine and 81,000 square feet of unused roof space, FedEx hired Sharp Solar to design this photovoltaic electricity system in 2005. Today, it supplies 80% of the facility's peak electricity needs.
We're looking at a system here that's 904 kilowatts, a very large system. Might be the largest system, rooftop system on a commercial building in the state of California. And it's composed of about 5,700 solar modules, and that large array uses about 300,000 silicon cells.
When sunlight strikes each of the silicon cells, it excites electrons, which are knocked free to form an electric current. Metal contact points carry the current away and complete the circuit. Typically, 40 solar cells make up a module. Several modules are combined into an array.
The power off of these arrays are ganged up, put together, and sent down through an inverter. That inverter changes DC power to AC power.
And that's it. In a split second, sunlight is converted into electricity, enough to power the beehive of activity below.
It can power a light bulb on a desk, or it could power the whole sort system.
One of the large benefits of solar power for commercial applications is that the system typically produces its maximum amount of power when utility prices are the highest, which is the middle of the day. When this system is putting out more power than the building is using, the power goes back into the grid and actually turns the meter backwards.
And the system is pretty much maintenance-free. So we're very pleased with that, and it's just another way that FedEx can lower our environmental footprint and still give great service to our customers.
What kind of environmental benefit can one rooftop bring? Over its 25-year guaranteed life, this one will offset 10,800 tons of carbon dioxide. That's the equivalent of removing 2,100 cars from the road.
Here, there's no turbine turning a generator. What happens here is that you use semiconductors, usually silicon, though we're starting to see a switch to cheaper materials, like where they can use a type of paint. They just paint a sheet of foil, and it just goes off something like a printing press, and potentially they can produce cheaply thousands and thousands of the photovoltaic cell. And as time goes on, it's getting cheaper and cheaper. But the main thing with photovoltaics is the expense, because the silicon for this is not cheap, and also it has to be protected with glass so it won't be harmed by the elements and stuff like that. Now, the way this works is that it comes in two layers. There's a P layer where the silicon includes atoms which are more on the positive side, and the N layer, the silicon, includes atoms that make it more negative. And then the photons, which are light particles, when they hit the silicon, they will knock off the electrons, and that makes that layer more negative. And then when you complete the circuit, like you do with the battery, where you say add a flashlight or your calculator, what that will do is that's going to complete the circuit, and the electrons will flow through the wire to the other layer, to the P layer, where the positive is. And once the current is flowing, then electrons can move directly from the P layer across that junction to the N layer. Electrons can't flow the other direction. And that's basically how photovoltaics works. The advantages to photovoltaics, these advantages and disadvantages also work for the power plants too, by and large, is that there's a very high net energy yield. They can be quickly installed and easily expanded or moved for the photovoltaics. One disadvantage, and this is one reason why I don't have solar panels on my roof, is because putting it up on the roof would void the warranty so we end up getting damage on there due to something like a hurricane, then the warranty wouldn't cover it. There's no carbon dioxide emission from any of the solar powers, except when it comes to producing it. The solar panels generally last 20 to 40 years. For those that are built into or on top of structures, you end up with very low land use with those. There's very low environmental impact, and they do work on cloudy days. The country which uses solar power the most is Germany. Like, the weather there is so bad that back during the Cold War, the very beginning of it, the Soviets decided to put a blockade around Berlin, and they figured that the United States would not stand a chance of being able to supply West Berlin by air because the weather around Berlin is profoundly worse than any city in the United States. But even so, in Germany and around Berlin, they use solar power because the solar power works even on cloudy days. Disadvantages are that you need access to the sun. Putting a solar panel up doesn't help all that much. You've got a big tree that puts the solar panel in the shade. It has a very low efficiency. The energy that hits the solar panel, only 15% of that energy will actually go to electricity. Compare that to the cars, which also have lousy efficiency. There, the efficiency is around 30%. So 30% of that energy goes towards running your car, and the other 70% just goes off as heat. It costs a lot. These things are expensive, though the prices do continually go down. One thing that does bring the cost down, though, is that in a lot of countries, in a lot of states, they give tax incentives. Like, say, in New York, if you put up solar panels, the state would end up paying part of the bill for it, and also you would end up having your property taxes reduced for about 10 years, and if you sold the house, that reduction in property taxes would continue. And even so, even though the high cost is upfront, it does pay itself back over time. For example, if you have solar panels up here that gets hooked up to the grid, you need an electricity backup system if you're powering yourself, if you're powering your home with this, because at night there's going to be no electricity coming from that. So you can store the electricity in a battery for the day. Or what's generally done here in the United States is that the power panels are hooked up to the grid. That way, what happens is that when it's not running, you're getting electricity off the grid. Electrical meter runs forward. What frequently happens in the spring and the summer is that your solar panels are producing more electricity than what you're using. So the power company will pay you for the extra electricity, and you'll see the electric meter is running backwards. Another disadvantage is that it's basically like a battery. And batteries are direct current, DC, and our homes run on AC, alternating current, so that DC current has to be converted to AC. We'll close by looking at developing countries. And in developing countries, particularly in rural villages, they're not connected to power plants. So they have no electricity whatsoever in their homes without solar. And this is about 1.5 billion people. They have to light their homes using kerosene lamps, which they have to purchase the kerosene for that. So in addition to the pollution from that, and pollution also from, say, cooking something by burning coal or by burning wood. So when they use solar power, it's a much cheaper alternative to kerosene lamps, as you'll see in this concluding video for the Vodcast.
My name is Musammat Farida Begum. I own and manage a tea stall. My husband and I set up this tea stall together. When there was no electricity, we had to use lanterns. Life was tough. We couldn't work, and the children couldn't study during the evenings. Back then, business was also slow. The bazaar didn't attract too many after it got dark. I first heard about solar home systems from a brother in the bazaar who highly recommended it. I then bought the solar home system for our shop. The system generates enough electricity for 4 lights, and I use 2 for my shop. I use the lights to keep the tea stall open in the evenings so that more customers come to my stall and I can sell more. I'm quite happy with it. My business is booming and my children can now study during the evenings and they are doing better at school. I'm earning more and I can afford better education for my children. I use the extra income to buy textbooks and school uniforms for them. Life is much better now. We don't need to ask for money or help from anyone. We are now self-sufficient and can look after our own family and educate our children. It means a lot to be able to do so. Solar home systems have transformed the entire Garjon Bunia Bazaar. Almost everyone now has electricity and are doing much better. Electricity allows us to run our business until 9 or 10 o'clock at night. The bazaar is thriving, everyone is enjoying prosperity, and I can sense happiness in the community. I can now envision a much brighter future for my family since I have access to electricity. My business is thriving, and I know my children will continue to do well in school. Similarly, I feel everyone in this bazaar can now aspire for a better and happier life.
Now we come to our concluding questions. Number 1, how does passive solar heating work? Number 2, how does a power tower work? Number 3, list 2 advantages to using solar power. And number 4, list 2 disadvantages to using solar power. That concludes this podcast, and I'll see you in class tomorrow.